So all of you, good evening. So coming back to gravitation. So we have seen gravitation, Newton's law of gravitation done. Then features of gravitational force done. Relation between G and G done. Variation of G with the height. Variation of G with the depth done. Those pages done. Gravity at the center of the earth will be 0. Weight of the body at the center of the earth will be 0. Gravity at the depth, gravity at the height relation done. Gravitational potential energy is also done. Then escape velocity expression is done. Orbital velocity expression is also derived. Relation between escape velocity and orbital velocity is also done. Next, time period of a satellite. See, time period of a satellite derivation is not done. So, I am planning to do the derivation of time period of satellite. This is the next topic which I am supposed to take in the gravitation chapter. Aaron, Aradi, Adira, Sri Sakti, Anugraha, Vidusha, Arjun Krishna, Vismaya, Ananya, Sanusha, all of you, good evening. So, today we are going to derive time period of a satellite. What is time period of satellite? It is a time taken by a satellite to complete one revolution around the earth. It is given by Siddhika. Definition we have already noted. Speed equal to what? Distance by time. Time equal to what? Distance by speed. Time equal to distance by speed. Satellite moves in what motion? Circular motion. This is, suppose this is Earth and satellite is this, moving with a radius r plus h. So time equal to what? Distance 2 pi into r plus h. Why 2 pi into r plus h? Because distance is actually what? To complete one revolution, distance is what? Circumference of circle with radius r plus h. Actual Earth radius is r. Satellite is at a height h from the Earth surface. Time equal to 2 pi into r plus h. What is speed? Speed equal to, here the speed with which satellite moves is what? Orbital velocity. So what is the equation for time? Time is equal to 2 pi into r plus h divided by speed VO. So time period is equal to 2 pi into r plus h divided by, what is the equation for orbital velocity? I hope you remember what is the equation for orbital velocity. Orbital velocity equation is what? VO is equal to root gm by r. Root gm by r plus h. Root gm by r plus h is the equation for orbital velocity. So, but we know that G is equal to what? Gm by r square instead of Gm. So, I can write what? Gr square. So, what is the equation for orbital velocity? Root Gr square by r plus h. Any doubt? Any doubt? Any doubt? Other doubt now? Any doubt? So, we are using this equation 2 pi r plus h divided by VO. Instead of VO, I am writing what? Root Gm by r plus h. So, T equal to 2 pi into r plus h divided by root Gm divided by root r plus h. So, T equal to 2 pi into r plus h, denominator r plus h moves to the numerator. So, root r plus h divided by root gm. So, T equal to 2 pi into r plus h, root r plus h is what? R plus h whole raised to 1 by 2, because we know that root x is what? Root x is x raised to 1 by 2. So, root r plus h is what? R plus h whole raised to 1 by 2 divided by root gm. So, time period is equal to what? 2 pi into r plus h whole raised to 1 into whole raised to 1 by 2. So whole raised to 3 by 2 divided by root gm. So this 3 by 2 I am writing 2 pi into r plus h whole raised to 3 into 1 by 2. So what is t equal to 2 pi? What is root raised to half? Root of r plus h whole cube divided by root gm. So what is equation for time period? 2 pi root r plus h whole cube divided by root gm. So instead of gm we can write what? Gr square. So this is the equation for time period of a satellite. 2 pi root r plus h whole cube divided by gr square. This is this equation is one equation. This is also equation for time period. Now special case. When satellite moves close to Earth's surface, height h is equal to what? H equal to 0. So t equal to what? 2 pi into r cube by gr square, which will give you what? 2 pi root r by g. 2 pi root r by g. So 2 pi root, what is r? Radius of the earth 6400 kilometer divided by g is what? 9.8 meter per second square. If you substitute, you will get time period is equal to 5078 seconds or 84.6 minutes. Time period 5078 seconds or 84.6 minutes. So remember, this is the equation for time period of a satellite. What is the standard equation? 2 pi root r plus h whole cube divided by gr square. But when satellite moves close to Earth's surface, height will be equal to what? 0. In that case, h equal to 0. So what is the time period? 2 pi root r by g. Any doubt? Any doubt? മക്കളെ മനസ്സിലായോ? നോട്ട് ചെയ്തെല്ലാവരും. നമ്മൾ എസ്കേപ്പ് വെലോസിറ്റി ഡിറൈവ് ചെയ്തു, ഓർബിറ്റൽ വെലോസിറ്റി ഡിറൈവ് ചെയ്തു, ഇപ്പൊ ടൈം പീരീഡ് ഓഫ് സാറ്റലൈറ്റ് എടുത്ത് 5078 സെക്കൻഡ് ആണ്. ശ്രദ്ധിക്കുക, പ്ലീസ് കോൺസെൻട്രേറ്റ് ഓൺ ദ സ്പെഷ്യൽ കേസ്. സ്പെഷ്യൽ കേസ് happens only when satellite moves close to earth surface. That is, height of the satellite above the earth surface will be 0. ആ കേസിൽ മാത്രമാണ് ടൈം പീരീഡ് 5078 സെക്കൻഡ്സ് കേട്ടോ. സ്റ്റെപ്പ് ഡൗട്ട് ഉണ്ടെങ്കിൽ ചോദിക്കണേ. What about others? All of you done? കഴിഞ്ഞ എല്ലാവരും എഴുതിയ വേഗം എഴുതി തീർക്ക്. പ്ലീസ് ഫിനിഷ് ഫാസ്റ്റ്. Ismaya done, Aaron done. What about others? Okay, I hope all of you done. Okay, let's continue. Next, height of a satellite above the Earth's surface. What is the equation for time period of a satellite? 2 pi root r plus h whole cube divided by 2 pi root r plus h whole cube divided by root gr square. Now, if you square this term, t square equal to what? 4 pi square r plus h whole cube by gr square. So what is r plus h whole cube? T square gr square by 4 pi square. So what is r plus h? Any doubt? Squaring we will get this term. So what is r plus h? T square gr square by 5 square 4 pi square whole raised to 1 by 3. So what is height of the satellite? T square r square g whole by 4 pi r square whole raised to 1 by 3 minus r. So this is the height of the satellite above the Earth's surface. This is the equation for height of the satellite above the Earth's surface. Please note down. Any doubt? Any doubt? Height of the satellite above the Earth's surface? Any doubt? Note it, height of satellite. Note it, height of a satellite above the Earth's surface. Next, so done. Next, geostationary satellite. Next topic is geostationary satellite. Geostationary satellite. A satellite which revolves around the Earth at its equatorial plane with the same angular speed. Suppose this is Earth. If a satellite revolves around the Earth, suppose this is Earth. Earth is rotating in this direction with angular velocity omega. If a satellite rotates in the same direction with the same angular velocity, the satellite will be appearing stationary when it is viewed from Earth. So whenever you are viewing from the Earth, the satellite will be at the same position because satellite revolves around the Earth in equatorial plane. Such satellites are called what? Geostationary satellite. A satellite which revolves around the Earth in its equatorial plane with the same angular speed and in the same direction as the Earth rotates about its own axis is called what? Geostationary satellite. So what is height of geostationary satellite? What will be the time period? Will be same as that of Earth, which is what? 24 hour, which is 86,400 seconds. Radius of the Earth is what? 6,400 kilometer. Gravity is 9.8. If you substitute time period 86,400, radius 6,400 or kilometer or 6.400 and raised to 6 meter, gravity 9.8, and these values, then you will get height of geostationary satellite is what? 35,930 kilometer from the Earth. What is height of geostationary satellite? 35,930 kilometers from the Earth. Geostationary satellite, and we are deriving height of geostationary satellite. Abhishek, good evening. Height of geostationary satellite. Done. So next, polar satellite. A satellite revolves in a polar orbit is called a polar satellite. A polar orbit is one whose plane perpendicular to equatorial plane of the Earth. See, there are two planes. Suppose this is Earth, then this plane is called equatorial plane, and this plane, red plane, is called what? Polar plane. This is polar orbit. Polar orbit. This is equatorial. Equatorial orbit. Means around the equator. What is the advantage of polar satellite? Polar satellite revolves around the poles. And as it revolves around the poles, Earth rotates about its own axis. So advantage of polar orbit is what? Whole Earth can be scanned. So it is used for military purpose. Polar satellite. A satellite that revolves in a polar orbit is called one polar satellite. A polar orbit is one whose plane is perpendicular to the equatorial plane. Equatorial orbit അല്ലെങ്കിൽ equatorial plane perpendicular ആയിട്ടുള്ള plane ആണ് എന്ത്? Polar plane. A polar orbit. A polar orbit passes over north and south pole of the Earth and has a smaller radius of 500 to 800 kilometers. As the Earth rotates about its axis, the polar satellite successively passes across the different parts of the Earth's surface. Thus, the polar satellite eventually scans entire Earth's surface So what is application? Military purpose. Military purpose. We just, with the help of polar satellites, we can scan all the earth. So we can check whether the enemy country is doing some activities against our country. Military purpose. Spy work. Spy work എന്ന് പറഞ്ഞാൽ മനസ്സിലായ? വിത്തൗട്ട് പെർമിഷൻ വേറെ സ്ഥലങ്ങളിൽ എന്താണ് നടക്കുന്നതെന്ന് അന്വേഷിക്കുക. അതിനാണ് നമ്മൾ സ്പൈ വർക്ക് എന്ന് പറയാം. അതൊക്കെയാണ് പോളാർ സാറ്റലൈറ്റിന്റെ പ്രത്യേകത. നോട്ട് ചെയ്യുക കേട്ടോ.
ചർച്ചകളൊക്കെ അങ്ങനെ പലതുണ്ടാവും.
നോട്ട് ചെയ്തോ? നെക്സ്റ്റ് ടോപ്പിക് ആണ് ടോട്ടൽ എനർജി total energy of a satellite. Consider a satellite of mass m. Consider a satellite of mass m moving around Earth with velocity VO, which is orbital velocity, in an orbit of radius r. Because of gravitational pull of the Earth, the satellite has a potential energy U is equal to what? Minus Gmm by r. Potential energy is what? Minus Gmm by r. Kinetic energy of satellite due to its orbital motion will be what? Let me derive this. Potential energy of the satellite U is equal to minus Gmm by r. What is the kinetic energy? Half mvo square, because velocity with which satellite moves is what? Orbital velocity. So half m into instead of orbital velocity, we are writing root gm by r plus h the whole square. So what is the formula? Half m into gm by r plus h. Okay, I am putting this r plus h as small letter r. Small letter r equal to r plus h. What is the kinetic energy then? Half m into gm by r. So this is the equation for kinetic energy. Or kinetic energy is equal to gmm by 2r. So what will be the total energy? Kinetic energy plus potential energy. So total energy will be what? Total energy will be what? Gmm by 2r plus what? Potential energy is what? Minus gmm by r. So it becomes gmm by 2r minus gmm by r. So what happens? E is equal to, if you take gmm by r common, gmm by r into half minus 1. So total energy is what? Gmm by r into minus half. Half minus 1 is minus half. So total energy is what? Minus gmm by 2r. Or you can write, we know that r equal to what? Small letter r plus h. So total energy is what? Minus gmm by 2 into r plus h. Both equations are correct. The total energy of a satellite is negative. It indicates that satellite is bound to Earth, which is a very important point. The last line is important. The total energy of a satellite is negative. What does it mean? Satellite is bound to the Earth. സാറ്റലൈറ്റ് ആരുടെ കൺട്രോളിലാ? എർത്തിന്റെ കൺട്രോളിലാ. അതുകൊണ്ടാണ് സാറ്റലൈറ്റ് എർത്തിന്റെ കൺട്രോളിലാണ്. അതുകൊണ്ടാണ് സാറ്റലൈറ്റിന്റെ ടോട്ടൽ എനർജി എന്തായി? നെഗറ്റീവായി. നോട്ട് ചെയ്താ? ടോട്ടൽ എനർജി നോട്ട് ചെയ്ത് കഴിഞ്ഞാ? എല്ലാവരും നോട്ട് ചെയ്ത് കഴിഞ്ഞാ? What about others? Done? Arati, done. Anugraha, Abhinav, done. Sita, Dia, finish. So what you are understanding from the final answer? The negative sign indicates that satellite is bound to the earth. Satellite ആരുടെ കൺട്രോളിലാണ്? എർത്തിന്റെ കൺട്രോളിലാണ്. അതുകൊണ്ടാണ് ടോട്ടൽ എനർജി ഓഫ് എ സാറ്റലൈറ്റിന്റെ ഇക്വേഷനിൽ എന്ത് വന്നേ? മൈനസ് സൈൻ വന്നേ. That minus sign indicates that satellite is bound to earth. സാറ്റലൈറ്റ് എർത്തിന്റെ കൺട്രോളിലാണെന്നാണ് അത് പറയണത്. ലാസ്റ്റ് എഴുതിക്കോളൂ കേട്ടോ. സാറ്റലൈറ്റ് ഈസ് ബൗണ്ട് ടു എർത്ത് എന്നൂടി എഴുതിക്കോളൂ. So we have done derivation of escape velocity, orbital velocity, gravitated height, gravitated depth, time period of a satellite, energy of a satellite, height of a satellite. Okay, done. So next topic, Kepler's laws of planetary motion. What is Kepler's laws of planetary motion? Kepler's first law, which is also called the law of orbits. What is Kepler's first law? Law of orbits. It states that each planet revolves around the sun in elliptical orbit with the sun situated at one of the two foci. FOCII. It is called foci, or some teachers pronounce it as foci. See, this is sun. Suppose this is the planet. Each planet revolves around the sun in what orbit? Elliptical orbit, with the sun situated at one of the two foci. See, this is called major axis, and the smaller one is called what? Minor axis. Listen, don't think that there are two sun. Only one sun. Sun will be either at this position or at this position. So each planet revolves around the sun in what orbit? Elliptical orbit, with the sun situated at one of the two foci. This is called what? This is called what? Kepler's first law, or law of orbits. Note here. Then draw this figure. The figure shows major axis and also minor axis. Next, Kepler's second law. Kepler's second law. Let me write that. Kepler's second law, or law of areas. Law of areas. What is this law? Let's see. Each planet, let me try the definition. Radius vector drawn from sun to any planet, covers equal areas in equal interval of time. Radius vector drawn from sun to any planet covers what? Equal areas in equal interval of time. Or you can say that aerial velocity of a planet around the sun is a constant. Another definition, you can write any of these definition, or mathematically dA by dt. What is dA by dt? Aerial velocity is equal to L by 2m is equal to constant. What is dA by dt? Aerial velocity What is L? Angular momentum. What is M? M, mass, which is also a constant, mass of satellite. So why aerial velocity is a constant? Because aerial velocity is L by 2m. Angular momentum is a constant when a body is in rotational motion. Then mass is also a constant. Mass of satellite. Now this law states that suppose at center we have sun. At center we have sun. See, this is a very tricky law, not easy to understand. See, suppose planet is here. So this is the area covered by the planet when it is closer to sun. When it is closer to sun. Suppose this is planet, this is the area covered by the planet. Now when planet is at a faraway point, see, still the area covered by the planet will be same. Area covered by the planet will be the same. That is the logic here. Area covered by the planet will be the same. Area covered by the planet will be the same. That is, this shaded area and this shaded area both will be same. That means what? Aerial velocity. Area by time is what? Aerial velocity. I will explain this topic in relation with the system particle and rotational motion. See, this is the axis or axis of the planet. Axis of rotational motion of the planet is through the sun with angular velocity omega. Okay. With this axis, planet rotates. When planet is here, suppose planet is here, what happens? R value is lesser because it is closer to sun. So R square lesser, mr square lesser, moment of inertia lesser, but angular velocity will be what? Greater. When angular velocity greater, V equal to R omega. So when angular velocity increases, linear velocity also increases. So when planet closer to sun, its velocity increases. Velocity increases. Now, when planet is away, so what happened? Planet at this position. So R value increases, R square increases, mr square increases, moment of inertia increases. What happens? External torque is 0, right? External torque 0 means what? Angular momentum will be a constant. Angular momentum L equal to what? I omega. Here L constant ആണ്. So what happens? And omega, moment of inertia increases. So what happens? Omega decreases. V equal to R omega. When omega decreases, V also decreases. That means what? When planet is away from sun, its velocity decreases. When planet closer to sun, velocity increases. When planet away from sun, velocity decreases. Any doubt? മക്കളെ ഞാൻ പറഞ്ഞത് മനസ്സിലായോ? ഡൗട്ട് ഉണ്ടോ? നോട്ട് ചെയ്യണേ, വളരെ ഇമ്പോർട്ടൻ്റ് ആണ് ലോ ഓഫ് ഏരിയാസ്. അതിൽ എല്ലാ ആംഗുലർ മൂവ്മെന്റ് ആണ്, മറക്കല്ലേ. എൽ ഈസ് ആംഗുലർ മൂവ്മെന്റം. ആ രണ്ട് ഷെയ്ഡഡ് ഏരിയയും സെയിം ആണ്. ദാറ്റ് ഈസ് ദ സ്പെഷ്യാലിറ്റി ഓഫ് ലോ ഓഫ് ഏരിയാസ്. Aerial velocity of a planet around the sun is a constant because aerial velocity is L by 2m, external torque 0, around the angular momentum is a constant, mass obviously a constant, so dA by dt is equal to L by 2m is equal to constant. നോട്ട് ചെയ്ത് കഴിഞ്ഞാൽ എല്ലാവരും ഓക്കെ. ലെറ്റ്സ് കണ്ടിന്യൂ. നെക്സ്റ്റ് കെപ്ലേഴ്സ് തേർഡ് ലോ. Kepler's third law, which is also called law of periods. Law of periods. It states that the square of the square of time period of a planet around the sun is directly proportional to cube of the radius. That is cube of the semi-major axis, but that semi-major axis radius. Cube of the semi-major axis. Semi-major axis means what? Major axis in a pagadi, which is nothing but radius. So it says that square of time period directly proportional to cube of the radius. So t square equal to what? K r cube. Suppose for one planet T1 square directly proportional to r cube. So T1 square equal to K r cube. And for another planet T2 square directly proportional to r cube. So T2 square equal to what? K r cube. So what is T1 square by T2 square? Let this be equation 1. Let this be equation 2. Equation 1 by equation 2 means what? T1 square by T2 square is equal to what? Kr1 cube divided by Kr2 cube. So T1 by T2 the whole square is equal to what? R1 by R2 the whole cube. Any doubt? This law is called Kepler's third law or law of periods. Note here. Kanya, also done. Finish. So we have done Kepler's laws also. Now let's move on. Now this question is a very important question. This question is a very important question. Why moon does not have atmosphere? See, due to the small value of g, the escape velocity on the moon surface is very small. Only what? 2.38 kilometer per second. The air molecules have thermal velocity greater than escape velocity. The air molecule on moon surface, what is the value of g in moon? Value of g in moon is very small, only what? 2.38 kilometer per second. The moon surface air molecules have velocity greater than their escape velocity. So what happens? The surface air molecule velocity is itself greater than escape velocity. So what happens? Surface air molecule will escape from away from moon surface. Why moon escape velocity is very small? Because moon acceleration due to gravity is small. So moon's acceleration due to gravity is small, moon escape velocity is small, but the surface air molecules average velocity is greater than escape velocity of moon. So they escape from the moon surface. They does not form atmosphere, which is a very important question. Note ചെയ്യുക കേട്ടോ. എന്തുകൊണ്ടാണ് മൂണിൽ അറ്റ്മോസ്ഫിയർ ഇല്ലാത്തത്? മൂണിന്റെ സർഫസിൽ ഗ്രാവിറ്റി കുറവാണ്, അതുകൊണ്ട് മൂണിന്റെ സർഫസിൽ എസ്കേപ്പ് വെലോസിറ്റിയും കുറവാണ്. പക്ഷെ മൂണിന്റെ സർഫസിലെ എയർ മോളിക്യൂൾസിന്റെ ആവറേജ് വെലോസിറ്റി, ആവറേജ് തെർമൽ വെലോസിറ്റി മൂണിന്റെ എസ്കേപ്പ് വെലോസിറ്റിയേക്കാൾ കൂടുതലാണ്. അതുകൊണ്ട് അത് എസ്കേപ്പ് ആയി പോകും. നോട്ട് ചെയ്താ? വൈ മൂൺ ഡസ് നോട്ട് ഹാവ് അറ്റ്മോസ്ഫിയർ. നമുക്ക് നോക്കാം നെക്സ്റ്റ് ടോപ്പിക്. Yeah. Next problem. A comet orbits around the sun in a highly elliptical orbit. Does the comet have constant linear speed constant? No. Why? Linear speed is what? R omega. As the comet rotates, omega will vary. So what happens? Linear speed will vary. Will the angular speed vary? Yes. Angular momentum L will be what? Angular momentum will be what? It will be constant because external torque is acting on it is what? 0. So angular momentum will be a constant. What are the two things constant? One is angular momentum, which is the right answer. And another right answer is what? Total energy throughout. Total energy will be throughout constant, but kinetic energy and potential energy will vary. So what are the things that will be constant when a planet revolves around the sun? Angular momentum, because we know that if external torque is 0, angular momentum L will be a constant. And always remember, total energy will be a constant. Kinetic energy, potential energy will vary, but total energy will be a constant. നോട്ട് ചെയ്യേണ്ട കാര്യമാണ് കേട്ടോ. നോട്ട് ചെയ്യട്ടോ. ഡൗട്ട് ഉണ്ടോ? ലീനിയർ സ്പീഡ് മാറും, ആംഗുലർ സ്പീഡ് മാറും, kinetic energy മാറും, potential energy മാറും. But who will be constant? These all are wrong answers. These all are wrong answers. Who will be constant? Total energy and angular momentum will be 0. Will be constant. Why angular momentum is a constant? Because external torque is 0, angular momentum will be a constant. നോട്ട് ചെയ്തോ? എല്ലാവരും നോട്ട് ചെയ്ത് കഴിഞ്ഞാ? So next class I'll be doing only problems from this chapter. Next question. It's explanation that is done. Next. Earth revolves around the sun in elliptical orbit. The closest approach of Earth with the sun is called perihelion. That is just for information. When Earth approaches the perihelion, its speed increases. Why? That I can explain. Suppose this is sun, and this is perihelion. Why perihelion? Because Earth is closer to sun. Earth is closer to sun. Sun should be bigger. So what happens? Earth is closer to sun. What happens? R value reduces, R square reduces, mr square reduces, moment of inertia reduces. So what happens? External torque is 0. So angular momentum should be constant, L constant. That is I omega should be constant. I omega constant, I into omega should be constant. But what is the problem here? What is the problem here? I value decreases. So angular velocity increases. We know that V equal to R omega. So when angular velocity increases, linear velocity also increases. Its speed increases. Speed is what? Linear velocity. I hope you understood. മനസ്സിലായോ? ഞാൻ എഴുതിയത് മനസ്സിലായ? എർത്ത് സണ്ണിന്റെ അടുത്താവുമ്പോൾ എന്താ പ്രശ്നം? റേഡിയസ് കുറയും, ആർ വാല്യൂ കുറയും, ആർ സ്ക്വയർ കുറയും, ആർ സ്ക്വയർ കുറയും, മൊമെന്റ് ഓഫ് ഇനർഷ്യ കുറയും. പക്ഷെ എക്സ്റ്റേണൽ ടോർക്ക് 0 ആയതുകൊണ്ട് ആംഗുലർ മൊമെന്റം L കോൺസ്റ്റന്റ് ആണ്. അപ്പൊ ഐ ഒമേഗ കോൺസ്റ്റന്റ് ആണ്, ഐ ഇൻറ്റു ഒമേഗ കോൺസ്റ്റന്റ് ആണ്, ഐ വാല്യൂ കുറഞ്ഞു. അപ്പൊ ഒമേഗ കൂടാണ്ട് വേറെ വഴിയില്ല. ഡൗട്ട് ഉണ്ടോ? മനസ്സിലായോ? ഞാൻ ഈ ക്വസ്റ്റിന്റെ അർത്ഥം മനസ്സിലായ? മക്കളെ ഇത് മനസ്സിലായില്ലേ? മനസ്സിലായോ? ഈ പ്രോബ്ലം ചെയ്ത് മനസ്സിലായ? എല്ലാവരും നോട്ടഡ് ആണല്ലോ. ക്ലിയർ സാർ കുറവാണല്ലോ. തിയറി കഴിഞ്ഞോട്ടാ, ഇനി പ്രോബ്ലംസ് ആണ്. നാളെ നമ്മൾ കുറച്ചുകൂടി പ്രോബ്ലംസ് ചെയ്യും. ദെൻ വി വിൽ ഫിനിഷ് ഇറ്റ് ഓഫ്. ദെൻ നെക്സ്റ്റ് വീക്ക് പുതിയ ചാപ്റ്റർ സ്റ്റാർട്ട് ചെയ്യും. മെക്കാനിക്കൽ പ്രോപ്പർട്ടീസ് ഓഫ് സോളിഡ്സ്. ഇവിടെയാണോ? പിള്ളേര് ഇവിടെയാണോ? ഓക്കെ. നോട്ട് ചെയ്ത് കഴിഞ്ഞാ? കഴിഞ്ഞ done, right? So next problem. Next is a lengthy problem. A Saturn year is 29.5 times the Earth year. How far is the Saturn from the Sun if the Earth is 1.5 into 10 raised to 8 kilometer away from the Sun? So it is based on Kepler's law. We know that T1 square, let this be Saturn, time period of Saturn square is equal to what? Radius of Saturn cube divided by time period of Earth square is what? Radius of Earth cube. Now what is Saturn time period? Earth time period is 1 year, and it is given that time period of Saturn is 29.5 times Earth year, which is 1. And what is radius of Earth? 1.5 into 10 raised to 8. We have to find out what? Radius of Saturn from the Sun. So what is the formula? Ts square. What is Ts square? 29.5 the square divided by time period of Earth square is what? 1 square. Saturn radius we don't know, so I am putting it cube only. What is Earth radius? 1.5 into 10 raised to 8 the whole cube. Any doubt? Any doubt? So Rs cube is equal to what? Rs cube is equal to what? 29.5 square into 1.5 into 10 raised to 8 the whole cube. That is Rs cube. So what is Rs? Cube root of 29.5 into 1.5 into 10 raised to 8 the whole cube. So 29.5 square. Cube root of here. If you solve this, it's not easy to solve without calculator. You will get the answer 1.43 into 10 raised to 7 kilometer. If you solve this, you will get the answer 1.43 into 10 raised to 7 kilometer. Solve ചെയ്താൽ ഈ ആൻസർ കിട്ടും. 1.43 into 10 raised to 7 kilometer ആൻസർ കിട്ടും. Any doubt? നോട്ട് ചെയ്യട്ടോ. ഡൗട്ട് ഉണ്ടോ? അതിൽ എഴുതിയാണ് നോക്കണ്ടാട്ടോ, ഞാൻ എഴുതിയണ പോലെ ചെയ്താൽ മതി. ഇത് സോൾവ് ചെയ്താണ് കേട്ടോ. ഇത് സോൾവ് ചെയ്യൽ ഒരു ടാസ്ക് ആണ്. സോൾവ് ചെയ്യൽ ലേശം പണിയാണ്. ആ മെത്തേഡ് അറിഞ്ഞിരിക്കണം. കഴിഞ്ഞ ഡൺ. നോട്ട് ചെയ്താ? അപ്പോൾ താങ്ക് യു ടാ. ഞാൻ ഇവിടെ സ്റ്റോപ്പ് ചെയ്യാണ്. നെക്സ്റ്റ് ക്ലാസ് ഫുൾ പ്രോബ്ലംസ് റിലേറ്റഡ് ടു ഗ്രാവിറ്റേഷൻ. സോ താങ്ക് യു സ്റ്റുഡൻസ്. താങ്ക് യു. ഐ എം ലീവിംഗ് ടുഡേ. താങ്ക് യു. ഗുഡ് നൈറ്റ്.